Hello everyone and welcome back to another project. In this project I'm going to show you the face recognition based smart and secure door lock including Internet of Things or IoT. So it's a computer vision based project that also incorporates automation and IoT or Internet of Things. So as usual, initially I'll be talking about the features of my project, then I'll be showing the components that I've used here, and finally I will dive into the demonstration the way the project works. So let's start with the features of my project. So if a face is recognized, then the door lock will be unlocked, and if it is not recognized, then an alert will be triggered using this AC bulb that will be flashing synchronous to a buzzer, and someone suspicious attempted to enter through the door or unlock the door. The image of that person who is not authorized, the image of that person will be saved into the local device as when sent to the corresponding user or the corresponding owner of the house via telegram. Now if the person wants to give access to the person to his home, of course he can unlock the door. So he can simply unlock the door by pressing on this button or from the IoT dashboard. So here is the IoT dashboard that I've designed to serve this purpose. Here is the unlock button. As you can see, if this button is pressed, then the door lock will be unlocked. The bell button will be showing you if someone suspicious attempted to unlock the door, and the door state, if it is red, then it's going to tell you that the door is locked. If it is green, then it's going to tell you that the door has been unlocked. And over here you can see a chart that shows you when the door was locked or when the door was unlocked. It's a graphical representation which is not that much required in case of our project, which does not serve any useful information, I should say. So that's all about the IoT dashboard. So right now I would like to talk about the components that I've used here. So as you can see, as the microcontroller, I have used the ESP32 board that comes with the built-in Wi-Fi that will allow me to connect with internet and perform different tasks remotely from the IoT dashboard. As the electric lock, I have used the 12-volt solenoid electric lock, and in order to trigger the flash alerts, I have used this red bulb, 220-volt red bulb. This 220-volt red bulb that will be flashing in synchronous to this buzzer to trigger the alerts. And as you can see, this run with 12 volts, this run with 220-volt AC, but the control signal generated by the ESP32 board is DC, and it's very small. It's of a 3.3 volt logic level. So the small DC control signal generated by the ESP32 board is not sufficient enough for driving these loads, for driving this solenoid electric lock, or for driving this AC bulb. So in order to drive this or switch these high voltage loads using the low voltage DC control signal generated by the ESP32 board, as you can see that I have used here the 2-channel relay module. As you can see, it's a 2-channel relay module. So the 2-channel relay module will be used to switch this high voltage load using the low voltage DC control signal generated by the ESP32 board. And as I've already told you that for alerting the person that someone unauthorized suspicious tried to unlock the door, I have also used a buzzer. I have used this pair of batteries in order to run my relay module, as it's a 5-volt relay module. But in together they will be generating 8 volts, but the relay run with 5 volts, so I have to step down the voltage. In order to serve this purpose, I have used this LM7805 linear voltage regulator that will be stepping down the voltage to 5 volts and driving it and deliver it to the relay module so that it can be energized. And I have used these 3 batteries in order to drive these drive my solenoid electric lock. And I have also used a touchpad or a touch button, pressing which you can easily unlock the door from inside. I mean, if you want to unlock the door from inside, it shouldn't require any kind of facial authorization, I should say. So that's all about the components that I've used here. And right now I would like to dive into the demonstration, the way the project works. And of course the project is scalable. For example, you have trained the entire system with let me show you, with 3 images. Say for example, I will be initially training the system with these 3 images, so they will be authorized. But it may happen that after a few more days you might want the access to be given to someone else. That means you might want your system to extend. So initially I will be, so in that case what you need to extend the database. Of course it is also possible to do. In our case I have kept that option, the scalability option. So I think I should dive into a demonstration that will make the things clear. So I had to write a Python script that will be doing the computer vision based part, and for driving my hardwares I had to write a code on CCPP and uploaded it onto the ESP32 board. So let's go to the code here. So first of all, what you have to do is generate the encodings corresponding the three images, these images, and then store it and then pack it to the pickle file. Of course you have to ensure that you are saving these images with a unique ID and the name. Doesn't matter if you don't give the name. I've just kept it for tracking purpose, but it's very important to ensure that you are adding a unique ID in case of all these users, in case of all these authorized users. And after that there is a database, root database, as you can see, that contains the information. Well, Emmanuel Macron and Neil Armstrong, they should not exist now. Let me clear them. Yeah. So you can see it contains the information 76. It should not exist as well. Yes. So as you can see, this root database Excel sheet contains the information of the authorized users. As you can see, I have the IDs and the names. Of course, you have to ensure that the ID that you are entering here is same as the IDs that were over here. So as you can see, Tasneem ul Haq Rafi 2024 9606 2024 9606. So make sure that the ID is correct, and after that, no matter if you increase the field, we don't really care about that. You can of course increase different fields over here about the person, but that really doesn't matter. What we are mainly interested about is the ID, because the code will look for the name with these IDs. We'll search for the names using these IDs, or we'll search for the name that corresponds to a particular ID. So that's all about the root database. So you have to create a root database right over here, as I have shown you. So I'm going to be saving it. So the first thing that you have to do is generate the encodings corresponding the three authorized faces. Let me go over there one more time. Where is it? Yeah. So we have to generate the encodings corresponding these three images, and then pack them or dump the encoded information as well the student IDs. In our case it is the person IDs or the authorized IDs into a pickle file. So right now I'm going to click here and generate the encodings. It may take around 10 to 12 seconds to generate the encodings. The greater the database, the larger the database, the larger the amount of time that it may take. So as you can see, the encoding is in progress. The encoding has started, and it should have been completed by this time. Why is it taking so long? So let me wait a bit. As you can see that the encoding has been completed and the pickle file has been generated. So if you go to your root directory, you can see encode file.p. It has been generated. That consists of the encodings. After that, what you have to do is you have to run the recognition. You have to run the main code. So what we do here is for the recognition part, what I've done here is I have unpacked the pickle file, unpacked the elements of the pickle file, which are the known encodings and the student IDs, and then for each of the incoming frames, I have generated the new encodings. That I really don't know if they are authorized or not. So I have compared the new encodings with the existing encodings, and if that matches, then the person will be authorized, and if that does not match, then the person will not be authorized. So that's all about the recognition part. So I'm going to my main code, door lock with face recognition. So I'll be running the code. Before that, let me ensure that I've plugged in all the components and powered up everything, all the hardwares. So let's wait a bit. Yes, I've plugged in the microcontroller. Let's plug in the bulb with the power socket. Yes, I have plugged in the bulb with the power socket, and right now I would like to run the code and see what happens. So I've run the code. It should be detecting the serial device. It may take a while. Yes, the serial device has been detected, and you can also see the IDs of the pickle files or the known encodings. And over here, as you can see that You can see my hardware setup over here. Here is my electric door lock. I believe you can see that enough clearly. Here is my electric door lock, and well, let me stay out. It already recognized my face. It should have not. Okay, so as I get my face within this virtual zone, the door lock will be unlocked because my face is already authorized into the system. And if someone unauthorized tries to unlock the door, then an alert will be triggered. So right now I'd like to get my face within the virtual zone and show you if it is working, if the door is being unlocked. So let's try to get into the virtual zone and see if my face is recognized and the lock is unlocked. You see, authorized the stimulography and the lock was unlocked as well. And after 3 seconds, it will be locked automatically by default. And you can check the updates over here that the door lock, door state, which is locked right now. And if you click here, then it should be unlocked. Well, maybe my device, yes, it's been unlocked. You see, and it's open once again. I believe you could see that it was green momentarily. Let me show you one more time. Clicking here, you see unlocked, and it's locked again. And if you want to, you can also do it from your cell phone. You can also unlock the door from your cell phone from inside. I mean, if you want to unlock the door from inside, then of course you are not going to scan your face. You can unlock it simply by pressing on the button as I've shown you from the IoT dashboard, or you can also do the same from your cell phone. So I'm loading my dashboard on my cell phone and show you if it's going to work. So you can see that I have a button over here. It's very difficult to show. I believe you can see. So I'm going to press here. You see the door has been unlocked. The state has also changed here. So let me try to unlock the door. So that's the IoT part. That's how the IoT part works. And if you want, we can also unlock by pressing on this touchpad. You see, here is the touchpad. Let me press it and you'll see what happens with the lock, which is right over here. I believe you can see it quite clearly, yeah. You see, it's been unlocked. And back to its main position once again. So right now, I'd like to show you with the other faces if it's working perfectly. Now let's show Iqbal's face and see if it is authorized. So just give me a while. Yeah. Sometimes it's a bit difficult for the program to recognize the face from the cell phone's stream, whatever. Okay, it was initially unauthorized, but later it got him authorized. That's because of the fact that I've scanned the face from the laptop screen, and my screen is not doing that much good. It's become yellowish. So let me try once again. You see authorized Iqbal Hussain Imon. The door has been unlocked and it is locked again. Now let me do the same with someone which is not authorized. For example, Emmanuel Macron, who is the president of the president of France, and let me try to unlock the door with his face and show you if it works. Well, the system works within the virtual zone. If you're out of the virtual zone, then it's not going to work. That's why I've kept my face out of the virtual zone, so that it may not recognize me for one more time, because I'm not interested to do so again. So let me show you if Emmanuel Macron is detected properly, if it is recognized properly. Okay, initially unauthorized. Let me wait a bit. Yes, you see unauthorized. And I believe you can also, I don't know if you could see the flashing of the bulb, because the screen was freezing momentarily at that instant of time. Maybe I'll attach a video towards the end. You see unauthorized and the alert was triggered, and the information that someone unauthorized tried to unlock the door will be saved here in the unauthorized log. As you can see, Emmanuel Macron was unauthorized and his image has been saved to our local device. As well, this alert is also sent to Telegram. I'm going to show you that the alert has been sent to Telegram that someone unauthorized tried to unlock the door. So here is my Telegram log. I believe you can see that someone unauthorized tried to unlock the door. Let me load my Telegram from my laptop and show that. more clearly. So let me get into Telegram. After that, I'll be scanning another unauthorized face. So doorbell, as you can see that it has sent me the alert that someone sent me the image of the unauthorized person who really tried to access the door. So we have got the Telegram alert as well. So let's check with another unauthorized face, say Neil Armstrong. You see unauthorized, the person was unauthorized, and I must be sent an alert regarding that very shortly. It may take a while, or sometimes due to the network connectivity it fails. So let me try to do the same for one more time. You see Emmanuel Macro being unauthorized. An alert has come to my Telegram. Both of the alerts have come right now. Unauthorized face 1212. So it corresponds to Emmanuel Macro. To Neil Armstrong, who is unauthorized. So the unauthorized attempts are saved to your local device as well. They are also saved to Telegram. So I'm done with the Telegram alerts. I believe I don't need to show you the Telegram alerts anymore. I'm quitting Telegram. And right now I'm going to show you the scalability. That means Emmanuel Macro and Neil Armstrong was unauthorized, and right now I want to authorize them. So what you have to do is to extend your database. So train new images, that means you want to add these two images to your database so that they are recognized, so that they can be recognized. So one corresponds to Neil Armstrong and the other corresponds to Emmanuel Macro. So you have to generate the encodings for these images, for these new images, and to do so I'm clicking here, add new images. This should be extended in my database, and it should be completed very shortly. Yes, you see the new pickle file has been generated, and you see I have two new IDs. So once I have these two new IDs, they must also be logged to the root database in order to extract their name while the code will be running. So I'm going there, root database, let me enter their name, 6, the ID will be for Emmanuel Macro, 20 must be same as the ID in the image file name, 202.11.005, and for Neil Armstrong the ID will be something like 1970 0101. So 19700101 2021 1005. So this corresponds to Emmanuel Macro. Maybe his date of birth says something like 5051980. And for Neil Armstrong, let's see, Armstrong, it should be something like 0109er, say 09er, and say what, 1950. So you have to save, you have to update your root database as I've shown you. The IDs must be correct. Let me cross check, 202.11.005.197.0101. Yes, they have matched. Maybe the video is getting a bit longer. I apologize for that, as the project has multiple features. It takes a while. So right now, as I've updated the database, I would like to show you if it's able to authorize and unlock the door with Emmanuel Macro. So you don't need to keep them here. As I have already trained them, I should paste them to this directory. So right now I'm going to show you if Emmanuel Macro is authorized. I had to pause the video for a while for some reasons. So right now I'm going to scan Emmanuel Macro and see if he's being authorized. As I've already added his sample to my database, added the encodings for Emmanuel Macro and Neil Armstrong to my database. So they must be authorized right now, but they were unauthorized a while back before adding the new encodings. So let's see if it works. You see that Emmanuel Macro was authorized and the door has been unlocked as well. So the alert maybe was for some kind of unauthorization reason, maybe it didn't detect properly in the next frame. And right now, if you scan your ID with the unauthorized ones, as usual, it will be giving you the errors. So let me scan an unauthorized ID and see if it works. Okay. So as you can see, an alert. I think you couldn't see that on the screen. The reason was the camera was freezing. So as I scan the unauthorized ID, as you can see, an alert is triggered. I believe you could hear that, but maybe I'll try to add a video, attach a video towards the end, just for letting you see the flashing of the alerts. You couldn't see the flash because the webcam couldn't get the stream from, couldn't get the flashes, because at that time it freezed, because during the recognition process the FPS greatly decreases. I believe you could see that towards the corner, that the FPS decreased during the recognition process. So that's all about this project. I hope you liked it. So I have shown you the security system, the door lock, that you can unlock following different approaches, like using the IoT, using GSM, using passwords, using OTP, using RFIDs, using iBlinks, using QR codes, using Face IDs. Like I've counted 8 numbers. So I believe it will play an important role for designing security system in practical aspects. So that's all now. Thanks for watching. Stay tuned for the next one. Bye for now.